Guys, this is Colin Hudnell, and welcome to another presentation video. It's going to be from Unit 5, Chapter 8, Reflection. We're going to start off with the primary colors. Um, it's a group of colors from which any of the other colors created by mixing the primary colors together. Like the primary colors here are blue, yellow, and red. And if you mix them together, so like red and blue, you can make purple, or yellow and blue, you can make green. Yellow and red, you can make orange. See, that's where the other colors come from, are from mixing together the primary colors. And here they are on the color wheel, as you can see. The next slide will be the secondary colors, which I just talked about just a second ago. Secondary colors are the end result of mixing together the primary colors. Like I just said, like purple, orange, green, like red plus blue equals purple, yellow plus blue equals green, red plus yellow equals orange. These are all secondary colors here. You can kind of see this little unique illustration of how red and blue equals purple, blue and yellow equal green, yellow and red equal orange, so forth. So yeah, that is secondary colors. Tertiary colors, they're the end result of mixing together a primary and secondary color. So for an example, like orange, which is a secondary color, and red, which is a primary color, will make vermilion. As you can see, like right here on this little color wheel-esque illustration here. And red and purple being a secondary color, will make magenta. Purple and blue will make violet. Blue and green, teal. Green and yellow, chartreuse. I think that's how you pronounce it. And yeah, and here they are on the color wheel. Well, this just says yellow, green, yellow, orange, red, purple. They don't really say the actual names, but yeah, you get the idea. Now there are analogous colors, which are analogous colors are colors next to each other on the color wheel that share a similar color. Like as you can see right here and here, like blue, violet, red, and red, or green, yellow, orange, or orange, yellow, and orange. They're all very similar colors. They're all like variants of the big colors. But they're all right next to each other. And here's an example of of just using analogous colors here. So because you're only using like the orange and the red, orange, yellow, and yellow. So yeah. So on to the next one. The next one is color temperature. Color temperature refers to warm and cool colors. When warm colors come forward while cool colors recede. So the warm colors, you could say, are more red, orange, and yellow, while more cool colors are blue, purple, and green, or light green. Here are some more warm and cool colors here. And as you can see, here's like a contrast between warm and cool. So, yeah. Saturated colors. Saturated colors refer to the intensity of the hue. So like all these colors you see here are really bright and vibrant, and they stick out a lot. And it might actually hurt the eyes a bit. So in your designs, it might not be a good idea to use very saturated colors because it can be very unpleasing to the eyes most of the time. But these are all really saturated colors. And here we have some like desaturated dark colors. It's a dark color that will become, desaturated dark color will become darker. Like say, like right here, you go down, it'll eventually become each color will eventually become so dark that it'll just become black, pretty much. Like Same here and here. It just goes, it's really dark. For like a desaturated light color, uh, desaturated light color will become lighter. So like it's kind of like it's the opposite here. Like going to the right of the scale, the red color will become much more light until it will eventually become pretty much white. Same here and here. Saturation. See, like it eventually each color will eventually become white pretty much if you keep going. Now RGB, which stands for red, green, and blue, refers to a system for representing colors to be used on a computer display or even like a phone display. It can be used to obtain any color from the spectrum. So like in a pixel, each pixel like on a display has red, green, and blue, and depending on the intensity or it'll like you could make it any color you want. Like I said, like this is a good example right here of how the RGB kind of works here. You're just mixing the colors together or lowering the intensity of one color to create another color. Yeah, so that's pretty much RGB. CMYK, which stands for cyan, magenta, yellow, and key being black, basically. It's the four inks used in printing. See right here's like RGB, and then here's like the same picture but converted to CMYK. See, it's a much more deep color. With CMYK, when something's printing, they use each color, each layer of color one at a time to create the image. So like here's some CMYK examples here. Like here's like the dot spectrum or whatever it's called. I can't remember. And then here's all the actual colors like cyan, magenta, yellow, and black. Here and next up we have the hexadecimal code, which is a positional system in which it converts 9 numbers to 6 numbers or letters that represent a specific color. Like, for example, like each color has a specific code to it. Like red would be FF0000, and then cyan would be 00FFFF, and so forth. And here are some more hexadecimal tables right here as well. And I think lastly here is spot color. Spot color is any color generated by an ink that is printed using a single run. It's pretty much like a solid color. It's not a mixture of colors. It's just using the one color. So like right here, so here's RGB, CMYK, then for print, and then offset print, spot. See, it's one solid color. Same with here, like red, green, and turquoise. Here's an example of using like spot here. So it's a pretty good example. Just solid red, pretty much. So, anyways, this is going to be the end of my presentation. I hope you guys enjoyed it. I guess I'll see you later.